Alright, we're back. Let's get the 47 crank out. That one's for the 46. So this is our V-twin crank. It used to be true in Osborne flywheels, and then they had their import rods. So let's see what's in here this time. It might be all import now. They didn't oil it and they didn't wrap it in plastic, so that's not exactly the best. That allows you to get some corrosion in there that you don't really want. Packaging is good though. Alright, so these are a lot tighter. Okay, these are done like Harley cranks. Wheels are made. They put the lock screws on here that don't do nothing. So these have a big S on there. I don't know what the S is supposed to mean. My guess is S is supposed to mean Sifton, which means it's V-twin private label. So these are Taiwan Teddy parts. Need to be made in Taiwan. The rods are your standard replacement rods. See that I say replacement right there, Harley rod. So these are standard cheapo rods probably. Maybe they're made out of better quality these days, who knows. Looks like we have one timing mark here, and I guess that would be a TD indicator over here. Nothing for the rear cylinder. Okay. These are a lot heavier than the S&S flywheels. See, the S&S flywheels are real thin. So these are a lot thicker. So this will give you more even running at low RPM. So these are stock. Those are hot rod. So, alright, so these don't tell you what they are, so you don't know what stroke they are. I don't know if these are 61 inch or they're 74. I'm assuming they're 74 because it looks like there's a pretty good gap in here. It looks like it's almost 2 inches, so that's 4-inch stroke basically, so that's the 74-inch number. 61's had a 3.5-inch strokes. They're a 1/4 inch closer together than the 74s. And 80 inch would be a 1/4 inch longer, so there you go. Alright, let's go see how these look. We got over here. Okay, here we got some kind of an Allen bolt and a very small taper. And that means it's going to be on screw threads, which I don't know how you're supposed to true that. That's kind of stupid. That is very stupid. How do you true something on a thread? Hopefully there's a taper under there. Alright, I'm going to go to my left hand. That's too big still. Yep. Hey, it's not metric. Okay, we know how loose S&S did theirs. Okay, this is a lot smaller screw. Let's see how tight it is. Oh, that's pretty tight. Yeah, about that much. How many foot-pounds is that? That would be tight there, see. Once again, quality control sucks. And that is a thread. There's no taper. And there's 2 screws in there. There's a lock screw. So you have a set screw and a lock screw. So that's how they keep them from falling out. But you actually have to jam the 2 nuts together, or 2 screws together. That one had no torque on that one. Yeah, so this is the one that you tighten this up in the bottom of the thread, and this one jams into it so it won't fall out. But you actually have to have them tight to each other to do that. So now the hole is open. There's no taper at all in there. There's only a screw thread. So that means it's impossible to true this crank correctly because you have no idea where that's at. That thing can flop around like this and you don't know it. There's no way of truing this crank. Garbage. If the crank is not true, it's going to shake your teeth out. Everybody thinks balancing is what's important. Truing is more important. Way more important. the crank's a little bit out of true, it really wobbles around. It makes a lot of vibration, especially when you got a big heavy ass flywheel like that. The other problem is I start beating on that thread, it's going to make it so the screw won't go in. That'll be another problem. So the way to fix it is you put it in a lathe and you center it all up and you put a counterbore or chamfer in there and Loctite the piss out of the screw and just have one screw. That's the only way to fix that crank. Alright, let's see what we got. Definitely heavy. Okay. Same deal, put as close as you can to each center without hitting anything. Horrible truing job. I don't know if you can see the needles bouncing all over the place, but it's not very good. So you can see how they're both moving side to side in tandem. So this one is, that one's high in the bottom. Where's this needle high at? And that needle's high on the top. So they're 180 apart from each other, which is really, really hard to compensate. That means you have to take the crank pin and go like that with it. It means the strokes, the flywheels have two different strokes in them, is what that means. Easily. So if one stroke is a couple thou more than the others, it's going to knock that out, the 4 thou that we have. Because it's 2 thou up and 2 thou down is 4 thou. It's like stroke and it doubles. So if their quality control is only within 3 thou, that's why you got a problem. So that makes it hard to true, and it's not the best. Now, how tight is this crank? Now remember that we're on the thread over here, so it's going to bounce all over the place. So this one's kind of a, we don't know what it's doing. Very inaccurate. Okay, so that one is high right in the center. That one's high right on the bottom. Now you can try blending the two shafts and make it kind of S shape. That helps a little bit. It's a give and take situation. Okay, this one's high, so this one I'm going to beat down. Stick that under there to support it. So this is going to make this side go down and hold this one up. And somebody stole my hammer. All right. Let's see what happened. Well, it moved. It moved a lot. So these cranks aren't very strong. Yeah, that one's really moving over there now. Okay, so now it is high down here because we hit it hard on that side. This one over here is also high down here because it was already high down there. So now it's just a matter of squeezing these together a little bit and see if that'll get us a lot closer than what it was. Now this clamp is probably not going to be big enough because the flywheels are too wide. See, it doesn't quite make it in there. The clamp's too small. Need a bigger clamp. Can't use this flyweight stuff over here. So where's a big clamp? So I can go over here on a wall over here and find me a big ass clamp to use somewhere. Let's see, how wide is that thing? It's pretty wide. I don't know if this one's any wider. This one here. We'll see. See, it's kind of laid up over here on the flywheel. See if it'll make it. It's probably going to be too short. It's going to be close though, like the other one. Oh, it just made it. Bingo! Okay, so now let's take this and go like that a little bit. This clamp is in the way, so put that right there. Alright, take that off. Alright, see what happened. That helped it a lot. It's back high on the top again. And that one's back high on the bottom again. Oh, it went right back to where it started from. What a shocker. So the next thing you do is try to bend the shaft in the flywheel. So this one's high right here, which means it's like that. So we need to hit on the high spot to try to bend this down. Too many clamps around here. Hit that one like that. And what I don't want to do is hit this other side of the taper in the flywheel, but oh well. Gonna have to do something. That side quit moving. This side's way out of whack. Okay, where are we at here? That one's high right at the top, same spot. This one's high on the top too, so it needs to go down more. So I'm gonna put this one right here. Hit it again. If you go and put in a hydraulic press and hit it on the bottom, it'll probably do what you want to do. I might have to do that too. We'll see. Ooh, that did not like that. It's high on the bottom now. So is that one. What are we hitting on over here? Not hitting on anything but it's making clicking noise. Nice. Must be a burr I'm hitting on or something. I don't know. Something. It might be bouncing on the thread over there. Okay, it's still high here. And this one's still high over here. So this shaft needs to go down to get the true up. So it's going to take some work to get this one up. But I'm going to tighten all these shafts up a lot tighter than they are now, so it doesn't really, this is a moot point trying to true this at this point. This one here is not going to true up very easy. Wasting my time is not really worth it. But this is definitely nowhere near as good quality as the S&S crank. So now we know that for sure. I always figured that anyway. Alright. Let's go over here and take it apart. I just want to get all these stupid set screws on, or lock screws and lock tabs that do absolutely nothing. I've seen so many flywheels with tabs bent out of the way and the shaft's loose. It's ridiculous. Those lock tabs do absolutely nothing for keeping that crank from coming apart. Absolutely nothing. So I don't use them, I use Loctite. Same as S&S. too big. Put the correct one in there, dumbass. That doesn't fit either. Feels like they got something on the screw. It doesn't just unscrew. Yeah, this thing fits worse than the other one. There's nothing on that screw. You smell for Loctite, there's no Loctite. It's tight because the threads don't fit. So see how the threads are all shiny on the top surface? The thread is jamming into the other thread because it's not made correctly. It's not supposed to be a locking thread. So once again, quality sucks. Alright, 1.25 inches. Should be 1.25 inches, I think. Oh, these are 5/16, that's right. Dumbass. That's 3/8 probably. Yep. 5/16. Oh, there's the right one. See, the other wheel is 1.5 inches because it had a bigger nut on it. The bigger nut on there, the more it holds the flywheel square. Even torque. Not very tight. They did use Loctite on there. That looks more like red. See, it has more of a red tint to it. So they used red. Blip, blip. Only got about half the thread has Loctite on it too. Versus S&S, they had a lot of Loctite on there. So this is your 83 later nut. This is your 54 nut. The nut before 54 was just a hex head that was real small. They didn't even have the flange on it. It was really weak. So you got 1, 2, 3. So two different ways of, two different nuts they use on the same crank pin. Except the 83 nut doesn't fit on that nut, on that flywheel. Unless the crank pin's made that way. Okay, this time we got the light hammer. That's probably all I need. Yeah, the light hammer's all you need in this one. The big hammer's better because a solid hit does more than a real hard small hit. You got a nice tap of that. Hit the crank pin square to pop it right off. So, once again, nothing is nearly as good as the S&S because S&S, the flywheel's a lot stronger. The taper is jammed in a lot tighter, and then it has sleeve retainer Loctite on it too. So this one here has no Loctite on the tapers, and the tapers are not nearly as good. Key's fairly loose too. There's your key. So these flywheels are made like stock with the thrust washers in there. And they're peened in. I don't want to peen in the top, that doesn't make sense. So these are just basic copy of kind of a stock flywheel. The counterweight's a little bit different how it's machined in there, but it's very similar. The S&S flywheels are obviously totally different. So same thing, they have a bigger nut on them. See how small that nut is? Bigger nut. They don't run a thrust washer in there, they just run right on the flywheel. Now, having a washer in there it actually allows you to rebuild it, which is nice. But S&S has stronger material, but it does still eats itself up. So it's still best to have a washer in there, but you know, it'd be one thing S&S could have done to do better. The other thing is you see there's a lot more counterbalance in here than this one. This has a real light balance on it, so this is a very lightly counterbalanced flywheel, so it's going to shake real bad probably. This one here has a lot more counterbalance on it, so it's a higher RPM balance. So they probably duplicated a Harley, which is really a low percentage. which is great for idle. Sucks for high RPM. So, that's just by looking at it. Now, I didn't measure it, so it might be not true, but just by initial looking at it, that's what it looks like to me. Okay, so now this one here has the aluminum cages in it, which is nice. Steel would be better, but the early steel, not the new stuff. Okay, those all come out. And now we have the rods to look at again. Now S&S, I didn't see what kind of a crank pin they got. I don't know if they're using a 2-hole or a 3-hole with the bearing still on it, so I can't see. This one over here is a 2-hole design. That's pretty good. Not a 3. Yeah, good. And the oil is in between the rollers, which is really nice. That allows it to lubricate more accurately. When you have 3 oil holes, they put it right in the bearing area, and that's not as good as being between. When you put the oil between the cages, it lubricates the bearings a lot better. So that's actually a good design. So that's a better design than the 3-hole. Original Harley had 1 hole, which is really crappy. And I don't know what size that is, how round that is. We're just going to look at these rods. I'm not going to be looking at the other stuff. So. Just like the other crank, we already set the diameter with our setting standard, so that's already set over there. So let me put this right over here. Let's see, this is going to go over here on the way. This thing's going to fall over if you don't put an angle to it. Right. Okay, so once again we're going to look at that needle over there and see how much it moves. I don't know if you can actually see that needle or not moving. Maybe pull up a little more, you might be able to. Okay, so S&S's crank was 7/10 out and 1/10 of taper. Okay, the diameter is about the same, dropped right in there at 3, -3. And either the gauge is broken or it's straight and true. Okay, wiggle that around a little bit. We got -5 in there. That's 4. That's 6. Flip around this way. It's 5, -5 again. Okay, so typical foreign made stuff. It's accurate. So it's 1/10. What was it? 2/10. Let me see this. That was just over 5. 4/10. 1.5 out that way. That's at 6, and that's basically 5. 5.5. It's all I'm saying. It's round on this side. It's a 1/10.5 out on this other side. So, like I said, typical China stuff, Japan stuff. It's accurate. They have good tooling over there. Good machines. S&S, no, they don't have good machines. Okay, now let's go check the big one and see if it's accurate. A little bit tighter, we're at 7. Whoa, now this one's not round. See, this one went down to 3.5 that way, and we're about 6.5 that way. Take it out, check it again. About 6.5 again, and that's about 3.5, 3 3/4. So the gauge is repeating. That's 5, and that's kind of low 3, going up to 4. Let's see here. That went up to 5, so 5 that way. Take it off. 5. My needle's a little sticky, so it gives you find a sweet spot where it likes it. It's about 4 that way, so that's about 1/10 out on that side. This other race, it was out a lot more. So 6.5 and 4, 2.5 out. Still, that's about on par with S&S's quality here, but the other one, S&S is way off. The sizing is about the same size too, so they're basically fitting this thing around 3 to 5/10 clearance. I mean, on the dial, and that's about the same on both of them. But once again, you got to measure the rollers, and you got to measure the crank pin, calculate your numbers, and find out what you really this should really be. But overall, these are straighter. These are a more round hole, which does not surprise me one bit. That is quite common. And if you think Harley parts are better, no, they're just as bad as S&S, if not worse. when you could buy genuine Harley rods, which you can't buy anymore, I don't think, so it doesn't really matter. Alright, so this crank has a lot of issues, but the rods seem to be halfway decent. Now, I don't know how strong these rods are. We'll find out when we go check the trueness of them. These are pretty weak, which means when you bend them to straighten them, they stay bent. Whereas S&S is a big spring, it goes right back to the same spot every time because they're really strong. Alright, so we're going to have to deal with this, where's the right side wheel? Not that one, it's too thick. Thin one's right side, right side. So that there is a major problem. So I need to put this into my lathe, indicate this thing in there to within a tenth, and come in here with a, I don't know how hard this is, probably a carbide center drill, and see if I don't break a $50 center drill off. Trying to make a chamfer in here so I can true it correctly. Because right now that's a joke. So Taiwan Teddy is striking out on their quality of the flywheel. What the hell is that supposed to be? Which is a big hole right there, isn't there? Oh yeah, they drilled real deep in that flywheel. Look how deep they went. They went almost 100% through it because that's the titty of the drill popping through right there. It's best if you don't drill the flywheel that deep. It's a lot stronger to have holes only go half or 3/4 in there, not all the way in. I would have put more holes in there. I don't like that. And that one went almost all the way in there too. Yeah. Be nice if it didn't go in there that deep. Oh well. We also have a big nick right there, but not too bad. Rough housing, not by me, but somebody. Alright, well there you go. These are basically stock like, except for the quality of the rod is softer, and then the that pinion shaft being made wrong is a real killer for me on using this crank. But the S&S, typical S&S, take it apart, rebuild it, put it back together. It's a good crank. Costs a lot more money, and you still got to rebuild it. But these have to be rebuilt too. So there you go. That is why I rebuild everything that's brand new. I rebuild because it's not to my standard of quality. All right, there you go. Two different cranks, same problems.